Hello, this is Dr. Hanaa Assil, and today we're talking about Group 7 halogens, and this is for the IAS chemistry. So you remember that halogens are in Group 7, fluorine, chlorine, bromine, iodine, and at the end there is astatine. Remember that as we go down the group, the atom gets bigger, more shells, more electrons. So the atomic radius increases as we go down. And we said that has to do with the reactivity. In the reactivity at the top is more reactive. So fluorine is a more reactive oxidizing agent because it's a smaller atom. It is more likely to accept electrons, and the electron that is being gained will have a strong attraction to the positive nucleus since it is nearer to the nucleus. As we go down, the atom gets bigger, so it becomes less reactive as a nonmetal or a less reactive oxidizing agent, since it will be more and more difficult to attract an electron to the positive nucleus that is further away. Then we said if we're talking about boiling point, then going down the group, fluorine, chlorine, bromine, iodine, these are bigger molecules. What kind of intermolecular forces between them? You should realize that they only have London dispersion forces or van der Waals forces, and these increase in strength as we go down the group because the larger atom will have more electrons, so stronger London dispersion forces that will need more energy to be broken. So as a molecule of fluorine, chlorine, bromine, and iodine, the boiling point or melting point, boiling point, increases as we go down the group. Now, if we're looking at appearance, we said fluorine is a yellow gas. As we go down the group, the boiling point increases and the color gets darker. So chlorine is a green gas, bromine is a reddish brown liquid, and remember that this is the only liquid non-metal in the periodic table. And then we said iodine. Now iodine as a solid, it's a gray solid. When we dissolve it in water, it is a reddish brown solution. But you have to remember that when we dissolve it in an organic solvent, such as hexane, it is purple in color. And the hexane or the organic solvent has lower density than water, and that means if I have an aqueous solution of iodine, that means the iodine dissolved in water. First of all, the aqueous solution is reddish brown, and it will be below the layer of hexane. The iodine dissolves in hexane to form a purple color, and this has lower density than water, so it will float on the top of water. Please pay attention to that. Then as we go down, astatine is a black solid. Okay, if we're looking at hydrogen halides, HF, HCl, HBr, HI, again, as we go down the group, the halogen atom gets bigger, and that means the bond between the H and the F will get weaker as we go down, since the bonding pairs of electrons are less strongly attracted to the positive nucleus that is further away as we go down. So this bond will need lower bond energy, and the one at the bottom of the group will be less thermally stable. It will also have to do with the acidity. Now, each of these should dissolve in water and ionize to form H plus ions, but the bond that is weaker as we go down will be more easily broken, so it will ionize more easily, and that means that the HI is a more acidic solution than the HF. Okay? Boiling points of the hydrogen halides. Now, we said boiling points of the halogens alone, fluorine, chlorine, bromine, iodine, as we go down the group, it increases. But then if we have hydrogen halides, we have another factor. As you see, the HF is the one that has higher boiling point, and then as we go down HCl, HBr, HI, the boiling point increases. Now, why is that? Mainly because of the type of intermolecular forces. Now, the HF is the only one in that list that can do hydrogen bonds due to the strong electronegativity of the fluorine atom. So fluorine is very electronegative. The bond will have a permanent dipole-dipole, and the molecules will have permanent dipole-dipole interactions, and of course the weak van der Waals forces, but they will also have hydrogen bonding between the molecules. And we said hydrogen bonding needs more energy to be broken, so the HF has higher melting point or boiling point than the other hydrogen halides. Now, as we go down HCl, HBr, HI, please do not say that they form hydrogen bonds, because we don't regard them as forming hydrogen bonds since it is very, very weak. They do have permanent dipole-dipole interactions. They have van der Waals forces. But as we go down, the increasing number of electrons in the halogen causes stronger van der Waals forces between the molecules, and that means that the boiling point will increase as I go from HCl, HBr, HI. Remember that the electronegativity also decreases. So as we go down, actually the dipoles become weaker. So because chlorine is more electronegative than bromine, more electronegative than iodine, so the electronegativity of the atoms decreases, and that means that the permanent dipole-dipole interactions will decrease, but the number of electrons increases, so stronger van der Waals forces, higher boiling point as we go down. So remember that HF is higher, and then we have HCl, HBr, HI in increasing boiling. Okay, so let us take a look at the reactions of the halides with aqueous silver nitrate. If you remember from the O level, we said to test for chloride, bromide, iodide, I need to add what? I need to add dilute nitric acid and silver nitrate solution. With chloride, I have white precipitate. With bromide, I get a cream precipitate. With iodide, I get a yellow precipitate. So this is what we said in O level. But then, as you notice, the colors are very close to each other. And when we're actually doing this test, it is very hard to determine if the precipitate is really white or cream or yellow. So we need to move on and do another test on that precipitate to determine if it is actually chloride, bromide, or iodide. So what we do is, the first thing we do is we should try to dissolve the precipitate that we get in dilute aqueous ammonia. If it dissolves in dilute aqueous ammonia, it is chloride, because you know that the silver nitrate with any chloride forms silver chloride, which is the white precipitate. Now, if this silver chloride can dissolve in dilute aqueous ammonia, or of course concentrated aqueous ammonia, to form what we call a complex, and this is soluble in water. So if the white precipitate dissolves in dilute aqueous ammonia, it is chloride. If it doesn't, then I try concentrate aqueous ammonia. Now, both bromide and iodide will be tested with concentrated aqueous ammonia. The bromide dissolves, the iodide does not. So remember, for all of these, we add dilute nitric acid and silver nitrate. The precipitate that comes out, if it is soluble in dilute aqueous ammonia, it's chloride. If it dissolves in concentrated aqueous ammonia, it's bromide. If it doesn't dissolve in any of that, then it is iodide. Okay, another reaction of halides is with concentrated sulfuric acid. You need to remember that when a chloride, potassium chloride or sodium chloride, whatever, reacts with concentrated sulfuric acid, it gives white fumes. This is because we get HCl gas and there is no further reaction. No further reaction because HCl is a weak reducing agent. It does not go on and react with sulfuric acid. So please remember that with chloride and concentrated sulfuric acid, we only get HCl and that's it. But then if we do bromide, actually the HBr that comes out from the reaction goes back and reacts again with sulfuric acid because it is a stronger reducing agent. So it reacts again with sulfuric acid, and what we end up with is sulfur dioxide and bromine. So remember, with chloride, we get only HCl. With bromide, the HBr reacts again to give SO2 plus bromine. Now, with iodide, because the HI is a very strong reducing agent, it continues to react with the sulfuric acid. So the HI that is formed at the beginning reacts with sulfuric acid again to form. It could form sulfur dioxide, iodine, sulfur, and H2S, which is hydrogen sulfide. And you should realize that what you will get is you could get a yellow solid. So the yellow solid will be due to the formation of the sulfur, and smell of rotten eggs due to the formation of the hydrogen sulfide. Do we understand that? So the HI reacts several times with the sulfuric acid to give a lot of products because it is a very strong reducing agent. Reaction with aqueous potassium hydroxide, and remember that this is the same as reaction with aqueous sodium hydroxide. So he could be telling you that we're reacting chlorine, for example, with potassium hydroxide on cold or hot concentrate. In both cases, they give different results. Now, when we're reacting chlorine with potassium hydroxide on cold, it will form potassium chloride, potassium hypochlorite, and water. So KCl and KClO. And remember, when we were doing equations, we said this is an example of a disproportionation reaction in which chlorine goes from 0 to -1 oxidation number, and that means it is reduced. It also goes in the same equation from 0 to +1 oxidation number, and that means it is oxidized. And we said if the same element is oxidized and reduced in the same reaction, this is called a disproportionation reaction. Now, with the hot concentrated potassium hydroxide, it will give KCl and KClO3. This is called potassium chlorate. So the chlorine changes from oxidation number 0 once to -1 and once to +5. Please know these reactions. You will be asked about. Another disproportionation reaction is when the chlorine reacts with water. Again, when chlorine reacts with water, this will give two types of acids, HCl and HOCl. So the chlorine changes oxidation number from 0 to -1, reduction, and once from 0 to +1, oxidation. So again, this is another example of disproportionation reaction. Reaction of the hydrogen halides with ammonia. Remember that we said the hydrogen halides are acidic. Ammonia is a base, so they react to form a salt, which is ammonium something, ammonium halide salt. If we are reacting hydrogen halides with water, dissolving any hydrogen halide in water will produce acids. So they will ionize. You can either say the HCl ionizes to H plus and Cl minus, or you can say it reacts with water to form what we call the hydronium ion, H3O plus the Cl minus. Another reaction of halogens is, we know that halogens are reactive nonmetals, so they will react with group 1 and 2 metals to form ionic compounds. And again, this is an oxidation reduction reaction because the metal, group 1 or group 2, will lose an electron. The halogens gain electrons. And remember that when we were doing balancing or writing overall ionic equations, we need to make the number of electrons the same on both sides. So this would be the overall ionic equation: 2 sodium plus Cl2 to give 2Na plus 2 Cl. Are we okay so far? Let's do some questions and answers very quickly. Now, this is the first question on this topic. Which test is used to show that sodium chloride solution contains chloride ions? Of course, you should remember that the test for chloride ions is dilute nitric acid and silver nitrate to give a white precipitate. So that's easy. When chlorine is reacted with hot concentrated potassium hydroxide, the chlorine undergoes disproportionation. What are the oxidation states of chlorine in the product? So again, let's remember, here is reacting the chlorine with hot concentrated. We said hot concentrated will give the KCl plus the KClO3. So the oxidation numbers change to -1 and +5. What are the gaseous products formed other than water vapor when concentrated sulfuric acid is added to potassium bromide? So remember, when we're reacting it with the bromide, we said it will form HBr. And then the HBr will go back and react to form SO2 and Br2. So my products would be bromine, hydrogen bromide, and sulfur dioxide. Okay? On adding chlorine to aqueous sodium bromide, the resulting solution is what? Remember that. Which one is more reactive? Chlorine is more reactive than bromine. So when we react chlorine with sodium bromide, the chlorine displaces it, forms bromine. What was the color of bromine? Reddish brown. So that is the color of the resulting solution. Two layers form when nonpolar solvent cyclohexane is placed with a dilute solution of aqueous iodine and left to stand. Again, we said if I have an aqueous solution of iodine, it is yellow or orange in color. Now, if you're going to add cyclohexane, an organic solvent, we said the iodine will dissolve in it, first of all, to form purple color, and then we said the cyclohexane has lower density than the solution, so the purple color will be the upper layer and the yellow color will be the lower layer. Given the following boiling temperature, select the likely boiling temperature for HF. Remember we said what was the relationship of the boiling point? We said the HF is the only one that is regarded as having hydrogen bonding, so it has much higher boiling point than the others, and then the others increase in boiling temperatures because more electrons, so stronger van der Waals forces. So which one would be the likely boiling point of HF? It should be higher than all of these due to the presence of what? Due to the presence of hydrogen bonding. So we would choose 293 as the likely boiling point. Which observations about silver chloride and silver bromide are correct? Now, action of sunlight. I want you to remember that this we did in O level when we said the effect of light on reactions. Silver ions are white or colorless. Now, if you put them in sunlight, all the silver compounds will have the silver ions taking electrons, so they will form silver, and silver is gray. So this will happen for any of the silver halides. So actually both silver chloride and silver bromide, if you leave it in sunlight, they will both turn gray. Now, the action of dilute ammonia, we said which one will dissolve in dilute ammonia? The chloride is the only one that dissolves in dilute ammonia. Do we remember that? Please keep all of this in mind. A solid silver halide was tested. The silver halide is which one? Action of sunlight, it turns gray. Well, we said all of them turn gray. Action of dilute ammonia, it does not dissolve. If it does not dissolve, then it's not what? Then it's not chloride, because we said the chloride would dissolve. So if he says it does not dissolve, that means it's bromide or iodide. Now, when he added concentrated ammonia, the solid dissolved. Well, which one will dissolve in concentrated ammonia? We said the bromide would dissolve. So my answer is silver bromide, because the solid dissolved in concentrated ammonia. If it were iodide, we said iodide gives a yellow precipitate that does not dissolve in dilute or concentrated ammonia. The most significant factor determining the trend in the rate of hydrolysis of halogenobutanes, we said, what determines the rate of breaking down of halogenobutanes? Halogenobutanes means alkanes with halogens. C, halogen bond. So what determines the strength is the bond strength of the carbon halogen bond. Okay? At room temperature, iodine is a solid, bromine is a liquid. What was the explanation for this? We said as we go down the group, the boiling point increases. So bromine is a liquid, iodine is a solid. Why is that? We said this is due to the weak intermolecular forces that get stronger as we go down the group. So it is actually because iodine has stronger London forces. Remember, they don't have permanent dipoles at all. Okay, and we don't say it's because bromine is more volatile. That's wrong. He's saying why is it solid and liquid and so on. So it is because iodine has stronger London force. Potassium halides can all react with concentrated sulfuric acid to produce what? What do all of them produce? KCl or KBr or Ki? They all produce hydrogen halides, because the first thing that will happen when you react any of these with sulfuric acid is it will give HCl or HBr or HI. Now, which one of the following substances forms when a few drops of concentrated sulfuric acid is added to sodium chloride? Again, I am going to add sodium chloride. This gives the sodium hydrogen sulfate as my product. Equal amounts of 1 chloro and 1 iodobutane are warmed with silver nitrate in the presence of ethanol. Why does 1 chlorobutane react more slowly? Remember, we said if I have Cl or Ci, which bond will break more easily? We said as we go down, the halogen is a bigger atom, so the bond is weaker and will break more easily. And that means that the CCl bond is stronger than the Ci bond. A halogen dissolves in water to form a yellow solution and in cyclohexane to form purple. Which one did we say does that? Iodine. You have to remember that. Which of the following describes the appearance of iodine under the stated conditions? So he's talking about iodine. As a solid, it is what? As a solid, I would choose gray. Now, dissolved in aqueous would be brown. Dissolved in liquid hydrocarbon, it would be purple. Please follow all of that. Solutions of barium chloride and silver nitrate are mixed together. The reaction that takes place is an example of what? What happens if I add silver nitrate to something that has chloride? We said it forms a white precipitate, so this type of reaction is precipitation. Which one of the following equations represents a halogen displacement reactions that can occur? So, for it to occur, the halogen that is reacted with the potassium halide should be more reactive than that halide in the potassium compound. So, which of these would react? You should realize that chlorine is more reactive than bromine. So if you have KBr plus chlorine, it would react. the silver halide, which is insoluble in water but soluble in dilute aqueous ammonia. So it forms a precipitate in solution, and then if you add dilute aqueous ammonia, it dissolves. That is which of these? The chloride. Remember that it is the chloride that will dissolve in dilute aqueous ammonia. The equation for the reaction of chlorine with water is shown. This reaction is an example of what? Remember we said this is an example of what? The chlorine changes from oxidation number 0 to -1 and 0 to +1. So oxidation and reduction for the same element. This is disproportionation reaction. Which of the following is not true of the hydrogen halides, HCl, HBr, HI? Forms white smoke? Well, you should realize that the HCl with ammonia, remember all of these actually with ammonia would form a white smoke of ammonium compound because these are acids and they would react with ammonia. So this is true. Dissolve in water to form strong acids? Yes, all of them form acids. Are usually prepared by the action of sulfuric acid on sodium halide? That would not be true because we said the HCl does not react further with the sulfuric acid, but the HBr would reduce the sulfuric acid, the HI would react again. So I cannot use this reaction to prepare hydrogen halides. Okay, so what is observed with a mixture of bromoethane and aqueous silver nitrate? Now, silver nitrate is reacting with something that has bromide. Remember, we said bromide would give me a cream precipitate. Give the equation for the reaction between chlorine and sodium hydroxide that forms sodium chlorate. You should remember that this is the one with the hot concentrated sodium hydroxide that forms NaClO3. That is the sodium chlorate. Please do not forget that the equation has to be balanced. Which of the following reactions is the most likely to occur when with chlorine in hot concentrated sodium hydroxide? Again, with chlorine in sodium hydroxide, concentrated will give NaClO3. This question says potassium bromide can be distinguished from potassium chloride by its reaction with silver nitrate followed by addition of aqueous ammonia solution. State what you would see on the addition of silver nitrate to potassium bromide. How could both dilute and concentrated ammonia be used to confirm that it is bromide rather than chloride? So remember that when we add dilute nitric acid and silver nitrate to something that has bromide, it gives a cream precipitate. Now, this precipitate dissolves in concentrated ammonia but not dilute. The chloride would form white precipitate that dissolves in both dilute and concentrated ammonia. The rates of hydrolysis of different halogenoalkanes can be compared by carrying out the reaction in the presence of aqueous silver nitrate. When an iodoalkane is used, the experimental observations would be, remember with the iodide, I get a yellow precipitate. Chloride ions in solution can be distinguished from other halide ions by the addition of silver nitrate followed by dilute aqueous ammonia. State what you would see again when it is added to chloride followed by dilute aqueous ammonia. So what we have here is chloride with the silver nitrate white precipitate. With dilute ammonia, the precipitate dissolves. Now, why the concentrated should not be used? Because both chloride and bromide precipitates would dissolve in concentrated ammonia. In the reaction of concentrated sulfuric acid with sodium iodide, the sulfur is finally reduced to what? So here we have sulfuric acid with iodide. Remember that we form SO2 and S and H2S. So which one do I have here? In the end, it would form H2S, so hydrogen sulfide. That's the final. A solid is soluble in water, produces steamy acidic fumes with concentrated sulfuric acid. What would this solid B. Remember that with sulfuric acid, if it gives white fumes, it is sodium chloride. Aqueous silver nitrate can be used to test for the presence of bromide. Write an ionic equation, include state symbols. So he's reacting silver ions with bromide ions. Remember that the silver ions are aqueous. The bromide ions have a minus on top of that, and that's aqueous. The silver bromide salt that is formed is a precipitate or a solid. It can be difficult to distinguish between the colors of the silver halide, so we use ammonia. A silver halide dissolved in concentrated ammonia. Explain why this result does not prove that the silver halide was silver bromide, and give a further test to confirm that the silver halide is silver bromide. Remember that we said if we add concentrated both silver chloride and silver bromide would dissolve. So you should use dilute ammonia. In that case, if it is chloride, it dissolves. If it is bromide, it would not dissolve. Thank you for listening. I hope it was helpful, and I hope you're able to understand all of this. And please listen to the next video. Thank you.